Hello there, scientific brilliant people. How are you today? So today we'll be discussing about the ray diagrams for convex lenses, and we know that the convex lens is a converging lens, and I will give you the method to draw the ray diagrams for 7 different cases. But before you start viewing this lecture, I suggest that you also view my lectures on rules for image formation and how to draw the convex lenses, and then you can begin with this video. So the links are already given in the description. Now let's start, people. So here we have a convex lens, and this is f, this is 2f. Now first case, we are going to keep the object at infinity. So people, infinity means the object is very far away from the lens, and I cannot show you over here because if I show you, then it would be very near to the lens. So practically you can understand that if we put a lens in front of the sun, then the sun is said to be an infinite object with respect to the lens. And we know that the rays coming from an infinite objects are parallel. So what we are going to do over here is, we are going to take parallel rays falling on the lens. So this is first ray, this is second ray, and make sure you don't forget to draw these arrows. So these are incident rays, people. Make sure they reach approximately half inside the lens. Now these parallel rays, they are parallel to one another, and they are also parallel to the principal axis. So after refraction, after passing through the lens, they pass through focus. Now we do know that when refracted rays meet, real image is formed. So at this point, since refracted rays are meeting, real image is formed, and we also know that real images are always inverted. So let's note it down that nature is real and inverted. Now position of image. So the refracted rays meet at focus. So wherever refracted rays meet, that point is the point of image formation. So image is formed at f. Now people, with respect to the size, you can use words like diminished, that means very small, highly diminished means very, very small, enlarged means big, and magnified also means big, or highly enlarged, highly magnified, such kind of words we will use. But right now I'm not going to discuss about size. We will discuss one case, and then I will be explaining you about the size. So here again the object is kept at infinity. Now in this particular case, the object is at infinity, so again the rays would be parallel, but this time the rays are parallel to one another, but they are not parallel to principal axis. So I am selecting two such rays. This is incident ray number 1, and parallel to this is incident ray number 2. Now these two rays are coming from an object which is at an infinite distance. Now we know that any ray passing from O goes straight, undeviated, without refraction. So this is our first refracted ray, and any ray passing through focus after refraction becomes parallel. Now we know that the point of image formation is the point where refracted rays meet. So here the refracted rays are actually meeting. So that means the image would be real, and the real images are inverted. So now if we consider the object to be an arrow, we have to show objects as an arrow. So here the image would be inverted. The head of the image would be down if we consider the head of the object to be up over here. Because with respect to the object whose head is up, this is real and inverted image. So image is formed at focus, position of image at f. Nature of image, again real and inverted. And size, as I said, we will be discussing after a particular case. So now let's move on with the other cases. Now what am I going to do is, first the object was at infinity, then I am going to keep the object beyond 2f, then at 2f, then between f and 2f, then f, and then finally between f and o. So I'm going to bring the object more closer to the lens. So we show the object by an arrow whose head is up, so like this. Make sure that you don't draw a very long arrow. The size of the arrow should not be more than half of the half of lens. So this is half the lens, and again it's half, not more than this much. Maximum, somewhat distance more than half the height of the half lens. Now we are going to use 2 rays for image formation. We may use more rays for image formation, but minimum number of rays required for image formation are 2. And the first ray parallel to the principal axis, half inside the lens, and after refraction it will pass through focus. Make sure you don't forget to put the arrows so that we know that in which direction the rays are going. Second ray directly from O, like this. So now second ray was passing through O, which will pass undeviated. Finally the rays are meeting at some point between f and 2f, so the image will be between f and 2f. Now since the refracted rays are meeting, it will be a real and inverted image. An inverted image means we have head of the image down, because here the head of the object is up with respect to that. This is a inverted image. Size of the image, as we can see, this image is quite smaller than the object, so we may write down smaller than the object over here. Now position of the image is between f and 2f. Nature of the image, real, and real images are always inverted. Size of the image is smaller than the object, or we can also choose to write down diminished, but as I said, I want to tell you something about size, so I am not filling this blank right now. Now here again the object is at 2f. Now people, no matter how perfectly you do the things, you will have problem in this case, because when the object is kept at 2f, the image is at 2f. Now no matter how hard you are perfect or how hard you try the diagram, in exams you may have an error. Sometimes you may get the image just below, before or after 2f. Then in exams you will have to again rub that and again start from the very beginning. So my suggestion is very simple. You draw an object, say of height 1.5 centimeter. Now make exactly 1.5 centimeter image at 2f, because we know that the image is going to be at 2f. So before drawing the ray diagrams, you are ready with your answer. Now first ray parallel coming from the head of the object, half inside the lens, passing through f, and make sure that you join the head of the image too, like this. Second ray directly from, you can take it from f, then afterwards it becomes parallel, you can use that also, right? But I mostly prefer this one. Join the head of the image O and head of the object. So second ray directly passing through O and finally meeting over here. As I said, people, you can also select the third ray. Any ray passing from f, after refraction it will become parallel, but it is going to meet over here only. So we see that the object and image are at the same point but on the other side of the lens. Since the refracted rays are meeting, real and inverted, and size is same as that of the object, correct? So let's write those points over here. Position of image at 2f again. Nature, so it is real and inverted. Size, same as that of the object, people. We see that the size of the object and image are same, but I'll fill it later on. So now moving on to the next case. As I said, we are going to bring the object nearer. So earlier object was at infinity, then here, now we are supposed to keep the object between f and 2f, right? So let's draw an object. My suggestion to the viewers is that don't make a too longer object, because then sometimes the image is very long compared to the object. It becomes very difficult to draw. So I am keeping the object between f and 2f. First ray parallel, passing through f. Another ray passing through O. I need to extend this a bit. Second ray passing through O goes straight away like this, and as we see, both the rays are meeting over here, correct? So I should not forget to put the arrow sign. Now here when I draw the image, the head of the image would be down because it is real and inverted image, because refracted rays are meeting. So as you see that the image is formed here, and I must rub this part so that viewers shall not get confused. So here this image is beyond 2f. So the position of the image is beyond 2f. Then since the refracted rays meet, the image is inverted and real. If refracted rays meet, it's always a real image, and real images are always inverted. Size of the image, it is enlarged, right? Now about the size, I will tell you that suppose if the point where the refracted rays are meeting, if that point is way below the principal axis, if this point where the rays are meeting, if it is way below the principal axis, then the size of the image would be very large. But if these two rays are meeting somewhere over here, then this point is very near to the principal axis, so the image size would be very small. If the point where refracted rays are meeting very far away, image size is very large. So here we can see it's an enlarged image. The image is enlarged. Now let's move on with f right now over here. So we are going to keep the object at f. First ray parallel, passing through f. Second ray passing through O. Like this. Now as we can see that these two rays are parallel, and we know that parallel rays never meet, right people? But still we make an assumption that these two rays are going to meet somewhere over at infinity. See, we know we are making a assumption which is not actually true. In maths, parallel rays never meet, we know that. But if you just stand on rail tracks, and if the rail tracks are going straight to a very long distance, and if you look at very long distance, you will see that the distance between the tracks keeps on decreasing. So if you are standing on a railway track, right, like if this is a railway track, and if you are standing over here and railway tracks are going straight, at a very long distance, it feels to us that these two, the distance between the two are getting lesser and lesser, and finally they are meeting. It is just like an illusion that if you watch from the terrace, you see that the earth and the sky meet. That's an illusion. We know that it is not true. In the same way, we make an assumption that these two parallel rays meet at infinity. So if we are making an assumption that these two rays are going to meet, the nature would be real and inverted. Now, position of image at infinity. Now, see the size of the image. Suppose if these two, if they meet over here, just imagine, if, which is not possible, if they meet over here, then this point is at a longer distance away from the principal axis. But they are not meeting here, they are meeting somewhere over here. If they meet over here, then the image size would be still longer. If they meet over here, then the size of the image would be very long. But these two are going to meet at infinity. So that means that point will be very far away distance from the principal axis. So the size of the image is highly enlarged. Right, people? Now let's also finish the size over here. This is smaller in size. We can also write down smaller in size as that of the object. Or we can also write down diminished. Here, same as that, same size as that of object. Now over here, in this particular case, look at this one, the size is, because infinity, the rays are coming from infinity and the objects in the infinity are like sun and moon. So compared to that, this image is very small. So we will write down over here as diminished. Now over here, as discussed, if this point is below the principal axis where the refracted rays meet, then the image size would be bigger. But if the point where refracted rays are meeting is very near to the principal axis, the size of the image would be smaller. And if it is on the principal axis, the image size would be very, very small. So highly diminished. Right, people? So now let's move on to our final case. In final case, we are going to keep the object between F and O like this. Like this. Now here first ray again parallel. Passing through F, first ray parallel, passing through F, second ray directly going from O, like this. Now we know that these two rays are not going to meet because they are diverging. So we extend them in the backward direction. To find the position of the image, we have to extend the rays if they are diverging. So this also again in the backward direction. And finally, I see that these two rays appear to meet from here. So if there is an eye somewhere over here, this eye will be feeling that these two rays are coming from the image somewhere over here, from the object somewhere over here. Now, since the refracted rays are not meeting, it's a virtual image. And virtual image is always erect. And direct image means head of the object up, head of the image also up. Correct? So the image is on the same side of the lens. So position of image on same side. Nature of image, it is virtual and direct. Size of the image, it is enlarged. You can also write down highly enlarged. It is because the image size is too big. Right? So hopefully guys, you have understood all the ray diagrams. If you